we've talked about abstractions, and abstractions come around an algorithm, and an algorithm gives us a series of steps that happen. And we talked about parameters, where parameters are what customizes each flow of that. And so variables come in a variety of forms in Java programs and all coding languages, where sometimes they're parameters, sometimes they're used locally. And defining and using variables becomes really eventually to be a forgotten part of your coding background experience and proficiency, but really an essential part of getting started. Using data properly, manipulating data properly is really important for getting good programs. So largely, our software programs, as you build them, are about decisions. You get inputs, you do something with them, and then you put them someplace else. And those inputs, there's a whole world of maps of different paths you go. You can see this picture here, this image is Moscow, and you can see all the different roads radiating out from that. And that's kind of like most of our algorithms. There's a whole number of things that could happen based off of the logic we allow to happen in, basically the things we enable the user to be able to do. And so programming is kind of like algebra. If you remember back to your algebra class at some point, I'm sure you've taken one somewhere, you had formulas like y is equal to mx plus b, a formula for a line. And so you had constants like m and b out there, and then you'd apply a value x and you'd get a value y. And that's much like what our code does. We get inputs like x, and we use other variables like m and b to calculate some result. And so the result we get is entirely based off of the inputs we get, and we can only accomplish that through the use of variables. If we just said y is equal to 2 times 7 plus 4, we have one answer and only one answer ever. So our source code is basically our way of communicating with the computer to tell it what we want to do. It's kind of sort of English-ish, but it has exactly perfect meaning to it. If I say to you, kind of go over there, you can interpret based off of hand gestures and other stuff what over there means. Where a computer, to tell it to go over there, I'd have to be very precise. Navigate to latitude 76.122.33, longitude, whatever that formula, that those numbers would be. I have to be exactly perfect with inside of that. And so source code becomes this tool that enables us to talk to computers and hand it logic to execute. But source code is not English. It's not just sort of express an idea and it's going to happen. If I don't use the exact perfect syntax, the exact perfect semicolons and curly brackets, and if the variable's name is X, I have to use the same X, not uppercase or lowercase. If the variable is actually a better name for a variable is student, I have to spell it properly. I have to have the capitalization done the same way. So code is not flexible. It's not loose in how we communicate. It's not UML. There's no variations inside of it. And so while we're learning what it is to deal with logic, we also need to learn what it is to deal with the syntax along the way. We have to be very perfect. It's not conversational in any way. So a lot of that is getting our data declarations proper. In Java, we have to be perfect in our data declarations. We have to give it a type. We have to define the variable in a legal way. And then we have to use them in very accurate ways. So here's some examples of that. We can see here we have some types such as int, that's a number, counting number, 1, 2, 3, 4, and minus 1, 2, 3, 4, 0, things like that. Boolean, which is true and false values. And in Java, we have very specific values for true, T-R-U-E, and false, F-A-L-S-E, all lowercase. And then there's some classes we'll talk about. We talked about that before. We define classes, we can create them ourselves. We'll talk about using them as types as you get further along in Java, but we can define other types of classes as variables. I can create a student object, I can create a teacher object, I can create a minor object, all the things we saw before. The important thing is every variable must have a type. Some languages don't require that. Like, for instance, JavaScript or Python. You can just say exposition out there. I don't have to define it as an integer. It might be a Boolean, might be a string, might be an integer, it might bounce between them. In Java, it's really important to tell the computer programmer what type you want. It's not for the help of the computer program actually. It's for the help of us. It helps us later on remember what we planned for this and have errors be caught by our compiler instead of after we go off and try and run this stuff. So the data type has to be either a primitive or a class, and then it's followed by the name of a variable and possibly a semicolon, or if we want to, we can initialize it like the double pi is equal to 3.14159. It's legal to, but seldom used. You can actually define multiple variables of the same type on the same line, as we can see right here. I don't encourage it. I really think it adds more confusion than it does help, but it is allowed inside of Java. So as we said, the valid variable types is we can have primitives out there. We can have object references, array references. We'll learn about those later on. So primitives, mostly what we'll see in this class is integers, doubles, and booleans. That's the type of things we'll be using. As far as classes, we might use things like string frequently. String is text. It's not just a array of characters. If you've ever programmed in other languages before, it's not just a bunch of characters together. String is a specific representation of text in Java, and there's other things in Java predefined like dates we can deal with. So we'll come back to these things later. Remember, we're going to spiral through this stuff and get more detailed through this class and into the next class. So one of the things you might have caught inside of there is the idea of assigning a value to a variable. Variables need to have a real value, normally a number or text or something like that. So the equal sign is used for that, and the equal sign can be used as part of the variable declaration, or it can be done later on. So we saw before, in this case, we have the variable the light is on and then my instance. And so we can say if the light is on is equal to is the voltage greater than 110. So you can see I'm doing this comparison right here. There's some probably integer value or maybe a double value here, voltage. And we're comparing that to, in this case, it's an integer literal. A literal is a number typed into code, 110. So if the voltage is over 110, then the light is on. Otherwise, the light isn't on, basically what it's saying. And then my instance is some object, and it's assigned to null, which means I have not assigned it to anything yet at this point. So that is the core behind assigning variables. Is I just have the variable name on the left-hand side. Here, use the single equal sign and then some value on the right-hand side. The fact that this is parentheses isn't super important here. That's not required. It's just shown as it's done here. You can just assign it to a value like we see here or a value like you see up here. It does require a semicolon at the end of any assignment. If you forget that, the compiler will tell it to you pretty quickly. So you have to get used to that. The semicolon is kind of like the I'm done now. This is the end of my thought. Continue on to the next statement. If you don't put a semicolon there, it's fine. You can go on to the next line. You can see, in this case, the light is on equals voltage. There's two different lines here, and that's fine. The thought doesn't finish until you get the semicolon. And so it's kind of like Java's use of the period. I'm done with this thought now, period. Oh, so the initial assignment later on. So variables in Java must be initialized when they're a local variable. There are special types of variables we'll talk about later, member variables or attributes, local variables explicitly within Java, and parameters have a special case too because parameters are assigned coming in. They are required to be provided by the user. But if I define a local variable, something temporary, like if you're keeping your checkbook or something like that, you have that ledger, you figure out how much is in your checkbook, well, you write down numbers in between. That's kind of like what a local variable is like. If anybody keeps checkbooks anymore, I haven't done it in 15 years. But anyway, local variable here is you have the sum local variable. It must be initialized before it's used. So if I wrote this code right here, sum, I've not initialized the variable to 0. It's not assumed it's a local variable is initialized to 0. So right here, if I try to equal sum is equal to sum plus 1, I would get an error such as this. The compiler said variable sum might not have been initialized because it hasn't been. There's no explicit code to initialize it. So I just have to, somewhere before I do sum is equal to sum plus 1, I'd have to explicitly tell it sum starts at the value of 0. Now, Java allows for constants. A constant is a special type of variable that only gets assigned one time. And so you can see that variable pi, I changed it now to be a constant value. Pi is a fixed value inside of there. So I do that by adding the keyword final there. The word final in terms of defining a variable, there's other places final can be used as well, means that this variable can only be assigned one time. That assignment might happen right now, or it can happen later on one time, but it does not change after it's been assigned one time. So in this case, double pi is equal to 3.14159. Notice here, when I make it a constant, the word pi, lowercase pi, became capital letter P and capital letter I. When I have multiple words, I have something like we see below here, days in week, so 3 words separated by underscores. That's the Java convention, the C convention for that matter, of how we make a constant, differentiated in code. So again, if we saw before, we saw variables like sum, we saw variables like, we saw it up here, pi. Well, when we make them constant, we make them capitalized at that point. So as we were saying, you can do a one-time assignment. So I can have a variable integer social security number. So if it's an existing system, I can look up their social security number, else I get a new social security number. This is fine. I don't have to have another temporary variable before I assign this variable or whatnot. Scope matters here. The important thing to understand is if I have a local variable, that's fine, I can do this. If I have a member variable, the rules change on that a little bit. Again, Spiral, come back to this later on when you understand classes, play with final again. But for now, just understand, when you see the word final, you get one assignment. The compiler will tell you if you're doing something wrong. So, as far as variable names go, variable names, as we talked about before, should match the thing that they represent in the real world. They should be verbose within reason. Don't have 50-character variable names, but don't have 5-character variable names. When people remove all of the vowels to make it less typing, don't worry about that. If you've done your tutorial inside of Eclipse, you'll know code completes out there. You can complete, based off the recommendations it gives you, and not have to type as much. And the compiled code doesn't care about the variable names anyway. It shrinks it all down. So the names start it with a lowercase letter. All variables should start with a lowercase, so it's easily identifiable compared to class names. Every word after that starts capitalized. The light, capital L, is capital I, O, capital O on. That's camel case, and this is true whether you're doing classes or variables or methods, but variables start with a lowercase letter. And then for constants, everything uppercase, and use them as underscores between the words. So that's the important thing there. So we'll learn more about operations as you go. They're pretty much the same way you use them as math. Plus, minus, multiply, divide, logical support for and, or, and not. And then you have a couple different assignments. You have the equal sign, but the double equals is a comparison. Is this value equal to the other equal? And then there'll be the dot operator, which we saw for calling methods. We saw that when we did system.out.println. That accesses stuff inside of an object. So I want to point these out to you just to remember that they're tools. I don't want to spend a bunch of time going over syntax and exact rules. There's stuff you'll just use, but think about them as you use them and play with them a little bit and learn them more. I do want to point out equality though. The double equals is for if today is Wednesday, or that's what's comparison. If I did something, if 2 plus 2 is equal to 4, that code will actually cause troubles. That code will not compile because you should have put equal out there. That's not the comparison out there. The important thing to understand is that in order to get anything done within the Java code, I have to have my code properly. And so, for instance, if I want to work with an object, I need to have something along the lines of an object and then that dot operator. And so that object is pointed to, my variable out there is pointed to an object, and that dot operator accesses the method, the data, whatever's inside of that. So we have the equality before equal, and then the dot operator, which allows us to access inside of that. So there'll be some demonstration on this stuff. We want to be able to go off and look at this stuff in action. These are some concepts that's going to get you ready for it. I can't cover every little thing and expect you to remember it. So my expectation is I'm going to mention some stuff here. I'm going to throw it out here. You're going to go through and you work on some demonstration. You're going to play with this stuff in code, and then you should play with it further than what I even give time for you here. These videos are 10 or 15 minutes. Little demonstrations here and there, but you should be spending probably similar time doing even more.